We're going to go through the process now of simplifying complex fractions. Fractions where the numerator or denominator or both contain one or more rational expressions. There's a few different ways of manipulating complex fractions, and we're going to go over two of the most common methods that we can use. Method one is a little simpler. Depending on the form of the rational expression, method one will often be the fastest. It's best when one or more of our parts of our complex fraction are just singular fractions and not multiple terms. The process is basically taking and simplifying the numerator and denominator to ensure that they're a single fraction, and then we perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the denominator. So for example, with this fraction up here, we have division of 1 over a divided by b over 2, and we can rewrite this as 1 over a times 2 over b. And we could do the same thing with this second fraction, where we have x over 2y squared times the reciprocal of the denominator. Now, this doesn't work if we have two terms. And so if we have two terms, we need to combine them over a singular fraction in order to do multiplication of the reciprocal. So let's go ahead and go through some examples. So here we're given our first fraction, and since we have just one term, there's no simplification that we can do with 2x and 27y squared. So we can just leave that alone. Now here, we can actually save ourselves a little trouble and go ahead and simplify this already to start. And if we reduce both of these by a factor of 3, we're left with 2 and 3 for the numerator and denominator. Then we have division of the numerator by the denominator of the complex fraction, which we can rewrite as multiplication of the reciprocal. And here now we can just treat it like one big fraction that's already partially factored. And we just look for common factors that we can eliminate. So 3 and 27 will reduce, leaving us with 1 and 9. We can eliminate one of the x's in the numerator and denominator. We also have the common factor of 2 that can eliminate, leaving us with 1 over, and then we have 9y squared and an x. Let's go ahead and do it again. We look and see that I have a singular fraction and a singular fraction, and no simplification can be done across the numerator or the denominator. So we can rewrite it as division, and then apply our division rule, where we are multiplying the numerator by the reciprocal of the denominator. So then we can go ahead and multiply across and consider this as one big fraction that's already factored. And then we can see that, well, 5 and 10 share a common factor of 5. So if we divide by the factor of 5, we're left with a 1 and a 2. So we're left to simplify x minus 2 in the numerator. And then we have 2 and x plus 2 in the denominator. Now here, since we have two fractions, we need to add the numerator and the denominator before we can do the division. So first we need to get a common denominator for the numerator, which is going to be y squared. So if we multiply our second fraction by y, we have x plus y over the common denominator y squared. And then we multiply the denominator, we get the common denominator of x squared, leaving us with y plus x over x squared. So now we have this big complex fraction where the numerator and denominator are each singular fractions. So we have x plus y over y squared divided by y plus x over x squared. And we can go ahead and use commutative property and write this as x plus y, and that'll come in handy in a little bit. We rewrite the division as multiplication. And then we go ahead and we look for common factors. Since the numerator and denominator both have x plus y, we can eliminate, leaving us with x squared over y squared. Again, we want to get a common denominator. X minus 4 and 4 minus x, well, these are opposites, So if we multiply our second fraction by -1, then we end up getting the common denominator of x minus 4 and changing the numerator to a -2, making that much easier to go ahead and subtract. 3 minus -2 is 5 over x minus 4. Then for the denominator, our least common denominator is x and x minus 4. So we need to multiply our second fraction by x minus 4 and the first fraction by x, giving us 2x minus minus 2x minus 4. Put that parenthesis in the wrong spot. We'll want to distribute the 2. And we are subtracting 2x minus 8, which means we're left with 8 over x minus 4. Bring this over, and now we have our full complex fraction with singular fractions. So 5 over x minus 4 divided by 8 over x minus 4. We'll change to multiplication. Five times x minus 4 over x minus 4 times 8. Well, we have the common factor of x minus 4, so we're left with 5x over 8. Now, we're going to do a couple of those same problems again, but using method 2. Method 2 is also going to be something we're going to be using in the future when we're solving rational equations, so it's a good idea to practice. Method 2, I find, is also going to be more helpful when we have multiple terms in the numerator or denominator. We identify the least common denominator of all the fractions within the complex fraction. Then we multiply the numerator and denominator of the complex fraction by that least common denominator. That allows us to simplify and condense the complex fraction into a regular rational expression. So you'll notice how a, b, and c are the same as b, c, and d from before, and we should get the same answers using a different method, and then you can compare how much work is involved. So here we have our two fractions. The denominator of my numerator is x plus 2, and the denominator of the denominator is x minus 2. So my least common denominator will be the product of those two. Now we're going to take the big fraction as a whole, and we're going to multiply it by x plus 2 and x minus 2. Just like when we're trying to find a common or an equivalent fraction, we multiply the numerator and denominator by the same factors. We're doing the same thing here. The benefit is, and I'm going to write this out the long way, is that when we multiply the numerator, as well as when we multiply the denominator, what happens is they'll cancel. Each fraction within our complex fraction will reduce, leaving us with a much simplified expression. And we went from having a complex fraction to a regular rational expression, and then all that's left is reducing where we can, leaving us with x minus 2 over 2 x plus 2. And it's the same answer that we see from before. Let's identify our LCD. The LCD of the numerator is y squared. The LCD of the denominator is x squared. So we can write it out the same way that we did here. And we're going to multiply everything by x squared y squared and x squared y squared, top and bottom. Now because we have multiple terms, this will be distributed. And so we end up with a little bit of a shortcut. And so the way I like to write this out if we want to write out the full thing, and then I'll show you the shortcut afterwards, but I want you to understand exactly what's happening here. We have all of our fractions within our complex fraction, and every single one is going to be multiplied by x squared and y squared. And so since we have x squared, y squared, and we're multiplying everything, we want to make sure that we can go ahead and simplify. Now here's how the shortcut kind of works. Once I've established what I'm multiplying, I kind of just write it with each numerator. Save myself a little bit of time. And then I can look at each numerator and say, okay, well, here, y squareds cancel, leaving me with x squared times x, which is x to the third. Here, one of the y's cancel, leaving me with y x squared. Down here, the x squareds cancel, leaving me with y to the third. And one of the x's cancel, leaving me with x y squared. Now my complex fraction has become a simplified fraction, so we just need to factor out. In the numerator, we have a GCF of x squared, leaving us with x plus y. In the denominator, we have a GCF of y squared, leaving us with x plus y. And since we have the common factor of x plus y, we're left with x squared y squared. Compare it to the one above. It's about the same amount of work. We'll see it come and shine in just a minute. So again, remember, these are opposites, so we can rewrite this fraction as -2 over x minus 4, multiplying the numerator and denominator by -1. And so we identify the LCD of everything, x minus 4 and x. So everything's going to get multiplied by the LCD of x and x minus 4. And then we look to see where we can simplify. First fraction, we're left with 3x minus. Second fraction, we're left with -2. In the denominator, we're left with 2x minus, and then we can distribute the 2. So we have 3x plus 2. Oh, I forgot the x up here. That should be a 2x. 3x plus 2x. And we have 2x minus 2x plus 8, leaving us with 5x over 8. And a little bit shorter than what we had before. And so both methods are valid. Use either one to simplify your rational expressions, but keep in mind the basic premise behind method 2 is something that we're going to come back to in the future. So I encourage practicing both. Now let's learn how to deal with these negative exponents. Now our negative exponent rules say that we want to write the reciprocal of these terms, but because we have multiple terms, we can't just move them around the fraction bar as easily as we have in the past. So we have to consider the expression. So x to the negative first, well, that's the same as having 1 over x to the first power. So that's our first term. Our second term, this is 2x times 1 over y, because we'll write the reciprocal of y, leaving us with 2x over y. Then we move to the denominator. We're going to have 1 over x squared. And then for the second term in the denominator, this is 1 over x squared times 1 over y, leaving us with 1 over x squared y. We can solve this using either method, method 1 or method 2. I'm going to solve by using method 2. identify my LCD. Of my x's, x squared is the highest degree, and of the y's, I just have y to the first power. So every single term is going to get multiplied by y. Let's use a different color we haven't used yet. X squared y, x squared y, x squared y, x squared y. So we'll go ahead and simplify. Let's do a pink. So one of the x's will cancel, leaving us with xy. The y's will cancel, leaving us with 2x to the third. The x squareds will cancel, leaving us with y. And the x squared and y will cancel, leaving us with a 1. Then all we have to do is factor to see if we have any common factors to reduce. We don't, so there is our simplified expression. Here we've got the reciprocal of 2x, so we want to write 1 over 2x plus 1. Here we have the reciprocal of x, so we have 2 over x minus 1. And we can take everything and multiply it by the LCD of 2x. Times 2x, times 2x, times 2x, times 2x. Our 2x's will cancel, leaving us with 1, plus 2x. Here the x's will cancel, leaving us with 4 minus 2x. And then last but not least, we can factor out a 2, leaving us with 2 minus x over 1 plus 2x. There's no common factors to reduce, so we're done.